Hey guys, today we're going to do chapter 8, section 4, area between two curves. So there are two things that you guys need to keep in mind when we're doing area between two curves. Number one, you need to look to see, are you reading up to down or are you reading right to left? So if it's y equals f of x, you're going to do the top curve minus the bottom curve. If it's x equals f of y, you're going to do the right curve minus the left curve. So I've gone ahead and done part A and part C and part D and part F by doing your graph here. So here's the graph of f of x. And then here's the graph of g of x. And we're going to find the value from 0 to 5 of f of x. And that region is going to represent the blue piece that you see here. And then we're going to graph the function. We already have g of x, and we're going to find f of 0 to 5 of g of x, shade that region green. And then how would you find the area that lies between these two curves? All right, so part B is integration from 0 to 5 of negative 1/2 times x minus 2 squared plus 6 dx. So we're just going to math 9, 0 to 5, negative 0.5 times x minus 2 squared plus 6 dx. And we get 145 over 6. And then we're going to find the value in part E of 0 to 5 of g of x. And that one's pretty simple, so we'll go ahead and do that one by hand. This is 4x minus 1/4 x squared from 0 to 5. Zeros are going to give me zeros. So 4 times 5 minus 1/4 times 5 squared. And that is going to give me 55 over 4. So for part G, to find the area between, you find that area by subtracting the area of the top, which is the top is f of x, and minus g of x on the interval from 0 to 5. This one is a top minus bottom. And we knew that initially because when we graphed it, we have f of x and g of x instead of f of y and g of y. So general approach for finding the area between two curves, the area between two curves algebraically of the ones that we just had, we're going to do from 0 to 5 of negative 1/2 times x minus 2 squared plus 6 minus 4 minus 1/2 x dx. And this one we said was a top minus bottom. And we're going to pretend like we have not already found the pieces. We already have found the pieces, but we're going to pretend like we haven't. So this is going to give us negative 1/2 times x squared minus 4x plus 4 plus 6, and this is minus 4 plus 1/2 x. So we're going to put all that together in one integral from 0 to 5. Negative 1/2 x squared plus 2x plus 2 plus 6 is plus 8 minus 4 plus 1/2 x. I'm sorry, I made a mistake here. This should be, we had 4. Half of 4 was negative 2. plus 6, which is 4. I did plus 2. All right, so the integral from 0 to 5 of negative 1/2 x squared. 4 minus 4 is 0. 2 plus 1/2 is 5/2 x dx. Differentiate, and you get negative x cubed over 6 plus 5/4 x squared from 0 to 5. So the 0 is going to give me a 0. So 5 stores x, negative x to the third over 6 plus 5/4 x squared gives me 125 over 12. Taking a look here at example number 3, it tells you that you have x equals equations. It shows you a graph that lets you know you're going to be doing a right minus left. So this time we are looking at the y coordinates and not the x coordinates. So negative 2 to 1. And we're going to do the top, or the right, excuse me, 3 minus y squared minus the left, dy, negative 2 to 1. We're just going to clean this up a little bit. And we get 2 minus y squared dy. Everything else is the same. You're used to using x, and this time you use y. So minus 1/2 y squared minus 1/3 y cubed from negative 2 to 1. So that's 2 minus 1/2 minus 1/3 minus, that's negative 4. That's minus 2. And that's plus 8/3. We're just going to do all that math right here in our calculator. 2 minus 1/2 minus 1/3 minus negative 4 minus 2 plus 8/3. And you get 9/2. If you have multiple points of intersection, that simply means you're going to have more than one integral. So the intersection of the two curves occurs where the two are equal. So the x squareds are going to cancel. And we have, if we bring, let's do this. Let's do 2x cubed equals, and then minus 18x equals 0. Take out the 2x and you get x squared minus 9. So you have intersections when x is 0 and plus or minus 3. So we have area 1 and area 2. Notice in area 1, the function is different. This is g of x, and this is f of x. So in area 1, the g of x is on top, and in area 2, the f of x is on top. So area 1 plus area 2 is your total area. Area 1 is from negative 3 to 0, and g of x is on top. So g of x minus f of x dx. So that is, g of x is x squared minus 4x minus 14 plus x squared minus 2x cubed. So area 1 is from negative 3 to 0 of 2x cubed minus 18x dx. So that's x to the 4th over 2 minus 9x squared from negative 3 to 0, which is 40.5. I've already done that calculation, so just to save us a little bit of time. A sub 2 from 0 to 3. This time f of x is on top. So f of x minus g of x dx. F of x is 14 x plus x squared minus 2x cubed minus x squared minus 4x. So our integral from 0 to 3 combine like terms and tie differentiate. And from 0 to 3, we get 40.5. So area 1 plus area 2 is equal to 81. For example 5, we have our sine curve here. We know it goes through 0. We have our cosine curve here. And our intersection points will be pi over 4 and 5 pi over 4. So we know that f of x is greater than g of x because it's on top. So f of x is going to be sine x and g of x is going to be cosine x. And our bounds are from pi over 4 to 5 pi over 4. And now we integrate. So our area is the integration of pi over 4 to 5 pi over 4 of sine of x minus cosine of x dx. Take the antiderivative of each one and evaluate that from pi over 4 to 5 pi over 4. So negative cosine of 5 pi over 4 minus sine of 5 pi over 4 minus negative cosine of pi over 4 minus sine of pi over 4. And you're going to want to use your unit circle here. So square root of 2 over 2, and then plus square root of 2 over 2, and plus square root of 2 over 2, plus square root of 2 over 2 is 4 square root of 2 over 2, which is 2 square roots of 2. And now we're going to look at area as an accumulation process, as we have already done. So f of x is an integration from -1 to the x value, whatever that may be, of g of t. So if we're asked to find f of -5, that -5 is going to go on top. So as we look at f of -5, it's an integral from -1 to -5 g of t dt, which is negative integration from -5 to -1 of g of t dt. So we need to break that up because we're finding the area, but we have a quarter circle here and a triangle here. So pi over 4 times the radius, which is 2 squared, just gives us a value of pi. And then this piece here is 1/2 times base times height, which is 1. So we're going to have to break that up from -5 to -3 g of t dt plus the integral from -3 to -1 g of t dt. So that's just going to be, let's see, from -5 to -3, -5 to -3 is going to be negative pi because we got our negative out front. And then we're going all the way to -1. So this piece is 1, and these two triangles are congruent. So this is -1. So that's plus 0, which is just negative pi. So f of -5 is negative pi. Part B, find all values of x on the open interval -5 to 4 where f is decreasing. So we're looking below the x-axis. We're looking to see where f prime of x is equal to g of x. And we're looking to see where f prime of x is less than 0, which we know is below the x-axis. And that occurs from -2 to +1. So f of x is decreasing on -2 less than or equal to x less than or equal to 1. Write an equation for the line tangent to the graph of f at x equals -1. So we're going to find our point by using f of -1 and our slope by using f prime of -1. So the integral from -1 to -1 of g of t dt is 0 because the bounds are the same. So our point is -1, 0. G of -1 is going to be the slope at -1, which is -2. So the equation is y equals -2 times x plus 1. Find the minimum value of f on the closed interval from -5 to 4 and justify your answer. All right, minimums occur at endpoints or where f prime of x equals g of x, f prime of x equals g of x, changes from negative to positive. So we're going to do a little chart here. And we've got -5 and 1 and 4. So we've got -5 and 4 are our endpoints. And then 1 is going to be where our graph changes from negative to positive. Well, we've already done -5. We did that in part A, and that equals -pi. And when we plug 1 in, when we plug in 1, we're going to get -2. F of 1 is our integral from -1 to 1 of g of t dt, which is just our area, in case you weren't real sure where that value came from. And it's going to be below the x-axis, so it's negative. And then we plug in 4, and we're going to get -1/2. So again, you can do that same thing there to get that value. In example 7, the density of cars on 10 miles of the highway approaching Disney World is approximated by f of x, where x is the distance in miles from the Magic Kingdom entrance. Find the total number of cars on this 10-mile stretch. So from 0 to 180, I'm sorry, I was looking at the wrong thing. From 0 to 10, 180 times 4 minus ln 2x plus 3 dx. And we're going to approximate that because we're going to use our math 9 here. Math 9, 0 to 10, 180 times 4 minus ln of 2x plus 3. And we'll do one more parentheses, dx. And we're just going to write that value down, 2,806.152 cars. As we know, we can't have 0.152 cars, but that is our exact value in terms of our calculator. All right, guys, that concludes section 4. I hope you guys have a wonderful afternoon. Let me know if you have any questions, and I'll talk to you soon.